Welcome back to Chem Sleeping Lab, Episode 8. Last time we talked about solvents. Tonight we will talk about two things that are often stored next to each other but never should be. Oxidizers and compressed gases. In episode 3, we talked about the fire triangle: fuel, oxygen, and heat. We said fuel is what burns. But what about oxygen? Does oxygen burn? The answer is no. Oxygen itself does not burn. Oxygen is not a fuel. Oxygen is an oxidizer. An oxidizer is a substance that helps fuel burn. It gives oxygen or takes electrons to let combustion happen. Air has about 21% of oxygen. That is enough for most fuels to burn normally. An oxidizer can be a gas, like oxygen. It can be a liquid, like hydrogen peroxide, concentrated nitric acid. It can be a solid, like sodium nitrate, potassium. Many fertilizers and pool chemicals are oxidizers. Why do we care? Because if you mix an oxidizer with a fuel, even without air, you have already brought two sides of the fire triangle together: fuel plus oxidizer. Now you only need a little heat, sometimes just friction or a small shock, to start a fire or an explosion. So a good habit is oxidizers and flammables live in different places, different cabinets, different trays. Like two people who argue, better keep them apart. Let us talk about oxygen gas a little more. Normal air is 21% oxygen. If oxygen concentration goes a little higher, say 23 to 24%, we call it oxygen enriched atmosphere. That does not sound like a big change, but it changes fire behavior a lot. In oxygen enriched air, things that normally do not burn easily can burn easily. Things that burn in air burn much faster and hotter. Clothes can catch fire more easily. Even a small static spark can ignite them. Oil and grease which are normally hard to ignite at room temperature, can burn violently or even explode in pure oxygen. That is why we never use oil or grease on oxygen regulators, valves, or fittings. On an oxygen cylinder regulator, you will see a warning: use no oil, because oil plus high pressure oxygen is fuel plus oxidizer, with almost no distance between them. Where can oxygen enrichment happen? Leaking oxygen cylinder in a small room, using oxygen for breathing without good ventilation. Even opening an oxygen cylinder valve can cause a brief high oxygen zone. And the opposite is also dangerous. Too little oxygen. If a large amount of nitrogen, argon, carbon dioxide, or helium leaks in a small closed room, it can push oxygen out. Air with less than 19.5% oxygen is called oxygen deficient. You may not notice it. You may feel dizzy, then fall asleep without smelling anything, because those gases are often odorless. That is why we never store large gas cylinders in a tiny, unventilated closet, and why labs have oxygen monitors in rooms with many cylinders. So, oxygen is not fuel, but it controls how fast and how easily fuel burns. Controlling oxygen and controlling oxidizers is controlling one side of the fire triangle. Now, compressed gases. A gas cylinder is a thick metal bottle with gas inside under very high pressure. The pressure can be 150 to 200 times normal air pressure, sometimes more. Why do we compress? Because gases take a lot of space. If you compress them, you can store a lot of gas in a small bottle. But high pressure means high stored energy, like a very tight spring. There are 3 hazards with gas cylinders. First, physical hazard, pressure. If the valve breaks off because the cylinder falls over, the gas will rush out of the small hole very fast. Second, chemical hazard. What is inside? It can be flammable gas like hydrogen, methane. It can be toxic gas like ammonia or chlorine. Third, Handling hazard. Regulator and fittings. A regulator reduces the high cylinder pressure to a lower usable pressure. Different gases need different regulators and different threads, so you cannot accidentally connect a flammable gas regulator to an oxygen cylinder. Never force a fitting, and never use an adapter that was not designed for that gas. How do we handle oxidizers and compressed gases safely in a calm lab? For oxidizers, 1. Store away from flammables and organics in a separate cabinet, cool and dry, not on a wooden shelf above a solvent bottle. 2. Keep away from heat and friction. Many oxidizers, especially organic peroxide, can decompose if heated and can catch fire by themselves. 3. Keep container closed and clean. 4. Do not mix waste. Oxidizer waste goes into its own waste container, not into organic solvent waste. For compressed gases, 1. Always secure. Chain, strap, cap on when moving. 2. Move with a cylinder cart, not by rolling or dragging. Never lift by the valve or cap. 3. Store by gas type. Flammables together, but away from oxidizers. Oxygen at least 20 feet away from flammable gases, or separated by a fire-rated wall. Toxics in ventilated area. 4. No oil or grease on oxygen cylinders. No oil on regulators, valves, gloves that will touch oxygen fittings. 5. Label everything. Full name, not just formula. And close valve when not in use. Then bleed the regulator. 6. What if there is a leak? For flammable gas leak, remove ignition sources. Ventilate. Close valve if safe. Leave area. For toxic gas leak, leave area. Call for help. Do not try to be a hero. For oxygen enrichment or deficiency, leave to fresh air and ventilate. In SDS, Section 2 tells you if it is an oxidizer or gas under pressure. Section 7 tells you storage. Section 10 tells you incompatibility, what it should not touch. Let us review tonight. Oxidizer does not burn, but helps fuel burn. Oxygen enrichment or oxygen deficiency are both dangerous. Compressed gas cylinders have high stored pressure energy, and inside can be flammable, toxic, or asphyxiating. That is all for episode 8.